Welcome to Pomodoro Joe for Friday, July 7th, 2023. Today we're doing LeetCode problem 2024. Maximize the confusion of an exam. This is a medium problem. A teacher is writing a test with N true or false questions, with T denoting true and F denoting false. He wants to confuse the students by maximizing the number of consecutive questions with the same answer, multiple trues or multiple falses in a row. You are given a string, answer key, where answer key index I is the original answer to the ith question. In addition, you are given an integer k, the maximum number of times you may perform the following operation. Change the answer key for any question to T or F, i.e. set answer key index I to T or F, so we can change up to k answers. Return the maximum number of consecutive T's or F's in the answer key after performing the operations at most k times. All right, then we have some examples here. So we have TTFF, k is 2, so we can change 2 of them. So we can either change both the T's to F's or both the F's to T's. Either way, we end up with 4. So the answer is 4. All right, example 2, TFTT, but k is 1. Well, if we change the T to an F, we can have 3 F's, or change this T to an F, we could have 3 F's. But if we change either the F's to a T, we can only have 2 T's. So the answer will be 3. That's right. Last example, TTFTTFTT, k is 1. So it looks like we want to change one of these F's to bridge the gap between these pairs of T's, and that'll give us 5. Okay. All right, we'll put 25 minutes on the Pomodoro timer and we will get started. So my initial thought with this one would be to do this recursively. We have k, we can basically change every possible answer, count it, reduce our k, and recurse. Now, we could do that, but I think that's going to take way too long. That's a lot of options. Basically, we can change every T to an F or every F to a T, or we could choose not to change them. So that's basically 4 recursions. Change T to F, don't change T, change F to T, or don't change F. So that's 4 recursions for every single call. I think that's going to be too much. The other thought that comes to mind, I think, is inspired by yesterday's video. And yesterday's problem, let's take a quick look at that. Yesterday's problem was LeetCode 209, minimum size subarray sum. Now in this one, we're given a target and a list of numbers. Now we have to create a subarray of the minimal length that has sum greater than this target, greater than or equal to this target. And the way we solved it was by creating a sliding window, and we would slide the window across this list of nums, but that sliding window would actually change in size. We would grow to the right and then shrink from the left. And it would sort of inch its way across this nums array. So I think we want to do something similar. So to approach this problem, let's think about sliding windows. We could have a sliding window of length 1, and we just go through. As long as we have a value in our answers, then we have at least a sliding window of length 1 that satisfies this requirement. So that was pretty easy. What about a sliding window of size 2? Now, we could have a sliding window that starts TT, and then it goes to TF, and then FF. So TT would satisfy that sliding window of size 2, so we could have size 2. What's interesting is this TF. That would not satisfy our sliding window of size 2 unless we had enough k to change one of those values. So in that case, this TF and a k of 2, we could actually change one of those values to have a sliding window of size 2 satisfy this. All right, what about sliding window size 3? Well, in this case, kind of the same situation as the TF before. We don't have a natural sliding window where we would have 3 in a row. But with our k of 2, we could actually change one of those values to have a size 3 sliding window. So one thing we could do is we could actually just start at size 1 and keep increasing the size of our sliding window greater and greater until we reach the maximum sized sliding window. But how do we know when we've reached that maximum size? And that's kind of where this k comes in. So if we have a sliding window, we have some window into our answer key. Can we change all of that sliding window to be either all T's or all F's? That's really what we're looking at. Can we take this subarray, this window into our answer key, and change all the values to be the same value? In order to do that, we could either change all the T's to F's, or we could change all the F's to T's. Which one would we want to change? Well, it really depends on which one has more. So basically, in order to change some subarray in our answer key to all one value, all t's or all f's. We want to find the answer that has the minimum representation in that subarray, so the fewest number of f's or t's. And if that number is less than k, then we can actually change all of those f's to t's or all of those t's to f's. So that's our key into solving this problem. If we have some subarray where the value of our t's or f's is low enough, it's below k, I should say the count of our t's or f's is below k, we can change all of those values so that they're the same. So now that we recognize that if we have some subarray window, we can get the frequency of each answer, trues and falses, find the minimal frequency and check it against our k. If that minimal frequency is less than or equal to k, we can change all of those answers to match the maximum frequency answer and basically have one block of solid trues or falses in our answer key. So while we could go through starting with sliding window at size 1, go to size 2, size 3, size 4, size 5, so on and so forth, that's a lot of redundant work. Now we'll take some inspiration from yesterday's video where we will slide our window from left to right, grow it to the right, but as soon as we reach this maximum where we can't add any more trues or falses because that minimum frequency has gone above k, then we can start shrinking that window from left to right until we get below k again, and then we can start growing the window out to the right again. So that's our approach to this problem. We'll have some result, and we'll return our result at the end. Okay, so for this we'll need to keep a couple things. We'll need our t count and our f count. Okay, so we have our trues and false count. Now we also need to have some window, so some start index, we'll set it to 0, and some end index, set that equal to 0. So this will be our window. The start and end indices define the window that we're looking at. So while we have some end index in range length of our answer key, so we're just going to start moving our end from left to right. We'll just cover the entire length from left to right. As we move this end, we'll need to keep track of our counts. So what is this answer? I'll call it a key for now. Maybe I'll call it answer. All right, so if the answer is equal to t, then we increase our t count. Otherwise, it's going to be a false, and we increment our false count. So we have our true count and our false count. Now we want to determine which one of these has the minimum frequency, or the smaller count, because that's the one that we'll want to be changing in our array. So I'll call it the min frequency, or min count. Let's do that. So whichever one of these has the smaller count, that's the one that will change. And now if this count is less than our k, then we can change all of those values and make this subarray all the same. So if min count is less than or equal to k, then we'll just change all those counts and we can update our result. Now the result will just be this window. Actually, the result will be either the result or this window. So we want to maximize this, so it'll be the max of our current result, or the window. And the window is our end index minus our start index plus 1. So if end index and the start index are the same element, we still have one element that we're counting. So end minus start plus 1. And at this point we can continue actually. Okay, what if we have a min count greater than k? Now if our min count is greater than k, that means we can't replace all of those answers with the opposite answer to make one solid window of either trues or falses. So at this point, we need to start shrinking our window from left to right. So for this one, we'll have to say, well, our min count is greater than k. Well, we need to shrink our window. So the first thing we'll do is we'll remove the answer at our start index. So that's going to be, let's grab this whole thing here. So this will be at our start index. We'll grab the answer at the start index. If it's true, we'll remove one true. If it's false, we'll remove one false. Next, we need to update our start index. So our start index will be increased by 1. So we're going to move it a little bit closer to the end index, shrinking our window. And then we do need to update our min count. So we'll have to grab this whole thing. All right, and I think this should do it. So we've got our true count and our false count, keeping track of the answers we've seen so far. We have our window that goes from start to end. We'll be moving our end index from left to right. As we move it, we'll keep track of our counts, and then we'll just keep track of which one of our answers has the minimum count. If we have some minimum count that's less than or equal to our k, we can just switch all of those answers and make this one solid block of either trues or falses. So then we'll update our result. It'll either be the maximum of our result or the current window, and we'll continue. However, if our min count is greater than k, that means that our smaller numbered answer actually has more values than we can flip. So we no longer have a solid block of either trues or falses. So we'll start moving our start index by subtracting our current value at the start index from our counts. Then we'll increment our start index and we'll update our min count. So we'll start shrinking our window, and that'll just be until our min count drops below or equal to our k. And at that point, we're allowed to make our entire block the same again. All right, let's see if this works. I have a bad indent. Yep, here we go. All right, I had a bad indent. Let's try that. Let's see if this works. Exceeded. What did we do wrong? Oh, this should be a 4. Duh. All right, there we go. Okay, so this works. Now there's some cleanup we can do in here, but let's just see if we can pass all the tests first. And we pass, and we actually do pretty well for our first pass. This is an 80% runtime and a 55% from memory. Yeah, that's not bad at all. So we can jump back in here and do a couple things. The first thing that I would do is change these mins and maxes. So let's do that. All right, we'll do this one too. I like doing this. So we've replaced our calls, our function calls to the min with our own min calculation here, and we've replaced our max call with this calculation. So this should give us a little bit of runtime savings. And we get a great savings. So we're now at 95% for runtime and 55% for memory. So that is awesome. All right, we can jump back in here and do a couple things. I don't know if I want to actually. So this is kind of ugly. Well, let's do this. This probably will take a hit on our memory and our runtime, but I think it's a little bit cleaner code. So number one, well, we don't actually need this end because it's going to be created here. Number two, we can have a counts out here, and we'll make this a dictionary. And we'll have two keys. We'll have T, and it will start at 0, and we'll have F, and that will also start at 0. So now we have true count and false count. And then in here, this answer key, we can make this our key. Then we can do this. Counts for this key plus equals 1. And we can do the same down here. Now counts for this key minus equals 1. And this is at start index. All right. Now our T count and F count, we'll have to pull these out of our counts here. So T counts. All right, so this cleans it up a little bit. And we do take a hit. So Now we're at 87% for runtime and 56% for memory, so we take a small hit by making these changes. Now, depends on what you're going for. Personally, I like this change better because it looks a little bit cleaner to me, just fewer lines of code to have to read through, but it's up to you. The other one's a little bit faster because it doesn't have to do this sort of lookup in our dictionary every time. Okay, well, we are down to about 5 minutes left, so I think I'm going to call it here. All right, so for this one, again, we did a sliding window type solution. We did a sliding window type solution where we had a sliding window that would actually change in size as we slid from left to right, keeping track of the frequencies of our count. Whichever count had the lower frequency, we could replace and have one array of all the same answer, or one subarray of all the same answer. All right, well, that is it for me. Hope you enjoyed this. Hope you had fun. Hope you learned something. Hope you can go out and write better code.